Hello, this is a video for assignment 2 for graphics for game. I am Tian Tian, a graduate student, so I need to generate the maze dynamically. Here is my assignment 2, and as you can see, there's nothing here, but actually I have added the maze actors. And in this video, I will first demonstrate the demo, and then I'll show the material, the randomized parameters algorithm to generate the maze, and then the encoding of the grid. At last, I will show a little bit of the code, the maze class that I implemented to generate the maze, and then the update logic to place the wall. First, I'll show demo. So here, I use two parameters to generate a maze. The first is maze dimension 2, 10, and the second is updates. I learned this in the last class taught by Mark. Here, if I click update, and the maze will show up. Yeah, it shows up here. And on screen, I also logged the maze size 2x10 and the maze build time 1.15 milliseconds. Here, this is a maze. Yeah, this is a maze, and this one entrance I have added it. And next, I'll show that it's dynamic and change the size at runtime, change it to 7, and then I click update. Look, here it's updated. This is the entrance, and then this is the maze. Okay, this is the demo part for the editing, and I will play it in the game sim. Here, yes, it's here. You can see it's running through it. Okay, this is the demonstration of the demo. Next, I'll show the materials I've created. This version is a little bug. If I open it and do some editing before it's loaded, it will crash. So I will stay until it is loaded here. Look here, this is a sphere that has the texture applied. And basically, I have two noise functions, and they are all variloid, and it will change according to time. It's very simple, so I demonstrate it here. They will output the color to the emission. Okay, this is the material I have used. Next, I will show the parameters algorithm I used in another screen. Okay, it's here. Sorry. Here's the randomized parameters algorithm. It just generates randomized maze, and I get how to implement it from the course website published by Dr. Anano, and the link, and I read it, and I found it really very interesting. Sorry. Here for the algorithm, the step is simple. You set up a writing initial frontier, dynamic generate writing location, writing grades inside the maze, inside grade, generate the grade position inside it, and then you mark the position inside the maze and generate the frontier. The frontier is just has the node that is directly labor of the maze cell. Here you will have 4 frontiers because you have had 1 grid inside the maze, and the next is a main loop. We will expand the maze until there's no front inside the grid, and for each frontier that we're taken, removed, and it's XY we will get the written label that is inside the maze, and then we can have the direction that goes from the maze to this frontier, and we will record that, because if there's a direction, which means there's no wall, and we will mark this position as inside the grid and hide the label that is not inside the maze as into the frontier, and we're doing this iteratively and until there's nothing inside the frontier. This is a basic algorithm. And here, for my maze, I encode each grid use 1 byte, and just as they did in the link. Here is a demonstration of how it looks like when the grid only has out value. It is like this. It has four walls by default, and this out and it has this gray color. And here shows it is inside the maze, and when the grid status is in, and it is just like this inside the grid, and it has 4 walls. And here is by default it is frontier, and it has 4 walls. And here I have 4 other visualization of the grid status of west, south, east, north, which means there's no wall to the west here, and there's no wall to the south, no wall to the east, no wall to the north. And for example, here this encodes the grid that is inside the maze, and it has no wall to the east, and the right side shows the 1 bit encoding. The first bit is safe, and the third bit is also safe. Okay, this is the basic algorithm and also the encoding, and I think it's efficient. Okay, next I will show the code that I've used for this maze. The code is here. Basically, the first thing is the maze class that I used to create the maze. This is the grid status I just showed. I also add a function to add entry point for the maze, and here the setup layout is the main function to generate or regenerate the maze based on the width and height. Here this is the algorithm, and here is those utility functions. I will go directly to the maze actors. In maze actor, at first I don't know how to get a reference to the plan and the material of the wall that I created. It's somehow interesting. You just right click the material or the plan that the material create, and just right click and you have a reference, and you just copy here its string, and I find this tag interesting. Okay, as you can see, here the second function is a construction function that I used to generate the maze. That is here when the user click update, and the maze will be updated. So this is generate the maze function inside the actor, then take out the whole bit of generating the maze and place the wall. Here let's have a look at the code of the generated maze. They basically have 3 steps. The first step is set up the maze parameter of width, height, and entry point, and then generate the maze. The second is clear the previous cached walls. We need to clear it, or otherwise there will be some segment fault. The third step is to place a wall. Based on the grid, I first place the west and south, and then for the edge case I place the east wall and the north wall, the east wall and the north wall. Okay, that's it. That's the major logic to place them. For the actually placing the word, I place that into another function here. I did some reference on the internet, some Google, and I found the for creating static mesh components inside the constructor of the actor and outside of the constructor of actor is different. I should call it different. Different interface to generate them, and then it says parameters that I have reference from the manipulator.cpp code and get them. Okay, this is the code and it works. Okay, thank you. Oh no, I don't want to exit. Stop recording.